does not have a lot of typical uses. This is generally done for proprietary Cisco-based routers. Those routers have some specific needs for this type of rollover cable. So that's where you'll see it used. Now the last type of cable that I want to talk about here is something called a loop-back cable. And the loop-back cable is one that is used to fool the computer into thinking that it's connected to another device. It's used typically for diagnostic purposes. In other words, you end up with wiring going in the cable, from the connector into the cable and then kind of back out to the same connector and right back into the computer. So basically the computer is going to send something out and it's going to go out wires that are going to be looped right back and plugged into the receive end of the computer so that it sends it to itself. You don't see this used too heavily. This again is used for diagnostic purposes only. So if you were trying to troubleshoot a specific network card, maybe the port, you want to see if the port's working, well then you would go out and get a loopback cable or a loopback adapter so that you would plug in to make it believe it was connected to itself. Alright, now the one last thing I want to tell you about these wiring standards before we move on is that straight cables and crossover cables, very often they are interchangeable with today's networking devices. And the reason why is because today's network devices have reached a level of sophistication to where they do what's called auto sense what type of cable is plugged in based upon what it's connected to on the other end. So very often you can take two computers, and if they have a newer network interface card in them, you can plug the two cables, take a straight through cable, and it'll realize, wait a minute, this isn't right, and then the network card will go ahead and reconfigure itself to go ahead and twist them around from a technological standpoint within the card on the chip. Or you could use a crossover cable, at which point it would say, oh, okay, we're on a crossover cable, so we'll work just the way we are. Same thing if you were plugging into hubs and switches and routers and things like that. So you need to know what these different types of cables are, but also understand with today's newer technology, you don't have to necessarily be that careful which one you're using. Now let's talk a little bit about LAN technology. LAN being local area network, right? So our localized networks within our office. And the most common form of network communication used in today's local networks is something called Ethernet. Now, there is another type of communication which very often is taught side by side with Ethernet, and it's something called token ring. But we're going to put token ring on the shelf for just a moment because we're quickly beginning to see that just go into non-existence. Okay, so Ethernet is primarily what we see out there. And Ethernet is something that is known as the 802.3 standard. Now, what the heck does that mean? Okay, so whoop-de-doo, it's a bunch of numbers and it's a standard. Well, let me tell you where that came from. If we wanted to get real technical here, I would tell you all about the IEEE, which is an organization made up of a bunch of geeks, which basically put together, they make a bunch of standards and stuff, and they created something called the 802 project model. And believe it or not, 802 is named after the year and month that it was created, back in February of 1980. But in that project model, there are a bunch of standards, and the one which is named 802.3 is the Ethernet standard. Or to be more technical, 802.3 is what defines something called CSMA CD access method. And that's what Ethernet uses. Ethernet uses this CSMA CD access method. Now, what the heck is that? Well, CSMA CD stands for Carrier Sense Multiple Access with Collision Detection. Alright, not getting real far, are we? You're probably still saying, alright, I haven't understood a word you said. Well, here's how Ethernet works. Here's how CSMA CD works. If we break apart what this all means, Well, first of all, we have multiple access. Okay, the multiple access component of CSMACD means that we have a whole bunch of computers and they're all connected to the network and they all have access to this network simultaneously, right? Multiple access to the network. The next part I want to talk to you about is the carrier sense part. And what that means is if I'm a computer and I have something I want to transmit to another computer, right? I need to transmit data out onto the cable. Well, I have the ability to kind of look out on the cable, almost like you're in a car looking to pull into the street. Look both ways and see if there's any cars coming. Well, we can sense whether the cable is currently being used, whether data is already being transmitted out on the cable. So that's what carrier sense is. Now, the collision detection aspect of CSMACD, well, as far as collision detection, it means just that. It means if we were to transmit data and that data were to collide, so let's say this computer and this computer both want to send at the same time, and even though they have the ability to sense whether the cable's being used, well, let's say they both simultaneously say, well, there's no one else transmitting, so I'm going to transmit. When this computer transmits, the data goes out on the cable and it travels in every direction along the cable. Simultaneously, this computer sends the data and it transmits in all directions along the cable. Well, eventually, the data is going to come to a center point and we are going to have a collision. And when that collision happens, data stops. Okay, the data did not get to its destination. Well, CSMACD has the ability to detect that a collision took place and that we have to retransmit. Okay, so the way CSMACD works is we have all these computers out on the network, right? All on the cable. And they all have the ability to check to see if anybody else is transmitting. If they see somebody else transmitting, then they wait. They wait for the cable to be free. They wait for the street to be clear. And then they go ahead and transmit their data. But in the event that two or more computers happen to transmit at the same time, well, then a collision happens. And when that collision happens, so in that instance where we had a couple of computers who both wanted to transmit, well, when they both send that data out at the same time, and then there's that collision, what happens is there's a random amount of time that each computer will wait before it attempts to transmit again. And the idea behind making it a random amount of time is that hopefully one of the computers will transmit first successfully, and then the other will transmit at a later time. And yes, it is possible that they could both theoretically wait the identical random amount of time, and then there, yes, might be another collision. And if there is, well, then we start the process all over again. I personally like to think of CSMACD as like a polite conversation. If you're having a polite conversation with another person and you have something to say in that conversation, what's the first thing you do? Well, you wait until the other person is done talking, right? So if we really want to analogize this, we're going to say multiple access in the sense that when you're talking to somebody, you both can talk to each other at the same, you both have access to speak whenever the heck you want, right? But you both have that carrier sense. You have the ability to listen to see if the other person's done talking. And it doesn't even have to be two people. Picture a room full of people, maybe in a boardroom, sitting around a table, right? You all have access to speak, but in a polite environment, you're going to listen to see if anybody else is speaking, and when there's silence, you then speak. But what can happen, even in a polite conversation? Let's go back to just two people. You talk, they talk. You talk, they talk. You talk, they talk. And then maybe there's enough of a pause, and you both had something to say. You both accidentally speak at the same time. And what happens? Neither one of you hear the other one, and you both stop talking, right? Transmission stops. unless one of you is that much more assertive than the other and you just speak over the other person. You continue talking. Typically, in a polite conversation, you both stop talking. There's kind of a somewhat of a random amount of time. There is no designated rule. One of you might gesture to the other to go first, but one person speaks first and then the other. That's exactly how Ethernet works. Okay, so that's how CSMA-CD works. Now, the next thing we need to get into is a bunch of the different standard, as far as definitions of different types of cable and cable speeds and things like that. And the first one I want to talk to you about here is something called standard Ethernet. This is actually old, outdated stuff. I can tell you that 10 base T was our old category 3 twisted pair cabling is what it would be used on. But you will see these types of standards, and what we need to do is define what 10 base T means. Now the first thing is that 10 and base and T are 3 separate divisions of this standard. The 10 represents how fast, and the 10 equals 10 megabits per second. The base represents either what's called baseband or broadband, baseband being digital, broadband being analog, and base equals baseband. And then the T represents what type of cable, and as I mentioned a moment ago, T equals twisted pair cabling. And the reason I said that this would be similar to category 3 twisted pair cabling is because we have the maximum of 10 megabits, which is what category 3 cable uses, or what category 3 cable can handle. Now, some of the other technology types we have is something called fast Ethernet, which is broken down into 100 base TX and 100 base FX. Now, you'll notice that both are 100 megabits. That's why we call it fast Ethernet. And some people laugh at that today because 100 is not considered fast anymore. It's considered adequate. But back in the day, when we used to have 10 megabit as our standard Ethernet, 100 was fast. So both of these are 100 megabits. That's what makes it fast Ethernet. Both are baseband. So the only thing that's actually different is the TX and the FX. The TX represents twisted pair cable, and the FX represents fiber optic cable. So 100 base TX would mean that we were using twisted pair cabling over a digital connection that could travel up to 100 megabits per second. Whereas 100 base FX would mean that we're using fiber optic cable over a digital connection with a maximum of 100 megabits per second. Moving along, we have something called gigabit Ethernet, in which we have 1000 base T and 1000 base X. Again, both are 1000 megabits or 1 gigabit, thus the name gigabit Ethernet. Both are baseband, both are digital communication. And the difference here is that the T represents twisted pair cable and the X represents fiber optic cable. Moving on from there, we have 10 gigabit Ethernet. And you'll see that we have a bunch of them here. 10G base T, 10G base SR, LR, ER, SW, LW, and EW. They're all 10 gigabits per second. They are all baseband. Really, what the determination here is between all these different specifications is the type of cable. The T represents twisted pair cable. The SR, LR, and ER represent fiber optic cable. And now this is where we get into the confusing part. The SW, LW, and EW specify communications with sonic equipment. And SONET is something that we will talk about later when we talk about WAN communications. And that's why I say this is where it gets a little bit confusing because, well, we're talking about LAN technology types. But if we're going to connect into SONET